Oh, and what we're going to be doing is walking you through how this whole setup is done. And we're going to complete our neutral safety circuit. And what we're trying to do here is just have something that is reasonably safe, reasonably secure, that we know that if one of the devices, one of our auto transformers breaks, we have reasonable protections put in place. So yeah, so what we're going to be doing is showing you how to wire up the control side of this circuitry. And you see I got a couple of things already wired up in here. Maybe gotta grab my pointer here. So we already have our hot legs that come out of the inverters, and those come down through the wire cableway, come up into here, and they come into this terminal block here where they are parallel together. So we have all these little connectors, and what these connectors do is they're something similar to this. And what these connectors do is allow you to join multiples of these Dinkle connectors together. And when we join those together, what we're doing is essentially we're paralleling the inverters right here, right when they come into the box. So this would be similar like what happens in a circuit breaker. So they come out of here in 3 different wires, and they come down in the contactor. These I'm choosing to use 2 contactors this time around, because what I'm doing is I'm going to monitor both legs. And the reason that I'm going to monitor both legs of the circuit is I want to try to do the earliest possible detection of a failure. If there is a detection of the failure, we want to shut it down. You'll notice that these contactors are a little bit smaller than the ones we've been using. So these are only 30 amp each contactors, and we've kind of got them wired in a little bit funny here. And I got this off of a forum post where a guy was saying that he was working at a company that built inverters, and their first generation of inverter had just these sort of contactors, and they stacked them up where they had red and then black, both on the same contactor, and they had several different contactors in the circuit. And what happens is when you try to turn that off, the load gets shifted to the contactors that are still on, and it will end up burning out your final contactor. So what we're doing here is we're just switching one full leg on each contactor, and we're also monitoring each full leg on our voltage protection relays. And so that will allow us to activate or deactivate an individual contactor. But if either one of these gets cut off, then the circuit fails, and it will not put out the required voltage, because our system is going to also involve this shunt trip breaker. And if either one of these is turned off, that shunt trip breaker is going to activate. And when that shunt trip breaker activates, it's going to kill the power output to our system. So that's the most desired effect. Is what we're trying to do is we're trying to protect the output. And that's what all of this circuitry is for. So that way our system never, ever, ever, for any reason, receives either one of these legs without a neutral and without both hot legs. So without further ado, we'll get on to the build, and I'm going to show you how to wire up the control circuitry to do all of this stuff. Let's get at it. So in the first part of the circuit, I want to talk a little bit about how do you turn it on and off. So the way that we turn this circuit on and off is we have this switch over here. We have our on-off switch, and this switch is going to control the voltage coming. So we're going to grab voltage off from our common rail here, and right here through these 2 fuse blocks, we've got 1 amp fuses in there, and through those 2 fuse blocks we're coming in, fusing that circuit, and then going out down along these yellow and blue wires. And I just chose yellow and blue because that's what I had on hand. And it comes into the back side of the switch, and we're switching both of those hot legs. We're switching the yellow and the blue wires with our on-off switch. And with that, what that enables us to do is we can switch this terminal block right here on and off. And what we're going to end up doing is we're going to take the power outputs from this terminal block here, and we're going to run them into these terminal blocks down here, and these terminal blocks down here are going to turn all these things on or off. So now you can see I've got these terminal blocks wired in, and what this allows me to do is when I turn this switch over here on, so if I turn this switch over here on, what's going to happen is power is going to come through this switch to these two terminal blocks here, and then be brought over to these red and black bus bars. Don't get too hung up on the colors here. I'm just using what I have sitting around. So the next thing we've done is we've went ahead and we wired up our shunt trip breaker. And so you see I've got this wire coming in to the bottom side. And this wire here, it comes all the way over, comes all the way up, and goes directly into one of the hot legs. And there's a reason why I'm not running it through this fuse. So this is an absolute failsafe, that if voltage is applied at both sides of this shunt trip breaker, this thing's going to kill this breaker. And so I don't want to have a fuse in here. If we have a fuse failure, our final fail-safe mechanism of activating the shunt trip, that won't happen if a fuse gets blown out. So what we want to have is this wire directly tied into our hot leg, and rely on the shunt trip itself, the protection circuitry inside of the shunt trip here, to function. So if you look at the shunt trip breaker, we can see that it's an AC. It will accept AC voltage from 110 volts to 400 volts, and it will accept a DC voltage 110 volts to 220 volts. So we're going to wire, we've got this one side wired directly into the hot leg, and then so out of the other hot leg, what we're going to do is we're going to come directly down to the NC side of our contactors. So if these contactors are closed, either one of these contactors closes, it's going to send a 220 volt signal to my shunt trip and kill this breaker. So let's go ahead and get the other leg wired up through the NC side of our contactor. Okay, so now we have we have a wire coming out of the other hot leg, and that wire is being split here at this cable, and it's going to both contactors. So it's coming out of one hot leg, going into the normally closed side of both of these contactors, and the normally closed is the top side. So you can see right in here where it says NONC, NO being this top one back here. Get a pointer. That's this one. The NO side is this one back here. The NC side is this one up here. So both wires come down into the contactors, and then they both come out of the NC side over to the other side of the shunt trip. And what this does is that either contactor, either this one or this one, fails and is closed and operating in normal conditions, what it's going to do is it's going to allow that other hot leg from up here to pass through and create a connection on our shunt trip, and that's going to trip the breaker. So this means that we can't have a condition where one hot leg is operational and then the other hot leg is not operational and still have this main breaker open, or I'm sorry, closed. We can't close this breaker without both of these contactors being active. Cool. So let's go on to the next steps. What we're going to do is we're going to wire up the voltage protector side of this circuit, and we're going to be using the normally open side of the contactors. We're going to come power out of here into the normally open, and we're going to do this for each hot leg because each neutral protection relay is monitoring an individual hot leg. You can see that I've already got the neutral side wired in, and that neutral side is just coming directly off of our bus bar here down to this bus bar here and this bus bar here. That's just passing the neutral directly in. So we'll go ahead and get that wired up. And like I said, we're going to be using one contactor for one leg and the other contactor for the other leg. And we'll come back when this is all ready to rock and roll. Just kind of wanted to show this a little bit. I'm about halfway through this. So what I've done is I've run a yellow wire out of this hot side. And this bus bar, it doesn't matter whether you come out of the top or the bottom. I've ran, in this case, I'm coming out of the bottom and coming through the bottom side of the contactor down here to this normally open side of the contactor. And the reason that we need to do that is we don't want to start measuring the voltage up here until this contactor is closed. If we start measuring the voltage up here, we'll get these weird readings on it. It won't work correctly, so we're wiring this into the normally open side of the contactor, so that way we don't even start measuring voltage up here until it's ready to start being measured, because it's got something into the auto transformers. So I just wanted to show you that real quick. Okay, and now the wiring is complete for our whole system. So let's go through what's going on here. So after I brought the wires out of the bottom side of the contactors, what I did is I brought them each up into the top side of these voltage protection relays. So you can see that yellow wire back there. So let's see if I can get in there. The yellow wire back here and the blue wire back here. And what that's doing is that's breaking the circuit that comes out from where it's switched over here, comes through here, comes up and around, goes into the top side of each voltage protection relay, and then comes out and goes over and goes into each one of these connectors here. So we've got this time I've used a yellow and gray connector, and that yellow and gray connector comes through here and then goes over and goes up into the top side of the contactor. But you'll notice some extra wires coming in here, and essentially what this is a bypass. And we're going to use some momentary switches to operate that bypass, and that bypass allows us to temporarily bypass the voltage protection relays. So the voltage protection relays themselves are set up for 120 volts, so they won't actually activate and turn on until they see 120 volts. However, these are 240 volt contactors. They need 240 volts to turn on. So we take each leg out of the bottom side of the voltage protection relay, run it into here, and if you measure across these two, you'd see that there's a 240 volt difference in there. So we need to temporarily be able to bypass this mechanism to jump start the system. So that's where these two momentary switches come in. And we've got this momentary switch here and this momentary switch here. And if I could find a momentary switch that would switch two legs at the same time, I would have only put in one. I couldn't, so I put in two. And so essentially what that allows us to do is bypass a voltage protection relay to turn the contactors on, allow the voltage to come through, comes out, goes down here to each one of our auto transformers. So our auto transformers will start making the neutral leg, which in turn will show up here. However, this might seem similar to the circuit that I had before, but the difference here is that there's never a time period where this system can operate without a neutral leg and then also have this shunt trip breaker not closed. So this not open. This shunt trip breaker is always going to be in a trip state unless the system is activated. And what this allows us to do is just have one simple step instead of operating a third contactor that once, that's how it was before, that once these two were active, when these turned on, it would activate a third contactor. What this shunt trip breaker allows us to do is essentially have a one-time reset. So we reset the system one time once it's turned on, and then once this whole mechanism up here, if there was a failure or something stopped or whatever happened, it's going to trip the shunt, and that's going to turn this breaker off no matter what. So that way, when we're priming the system, what we're doing is we're ensuring our system never, ever, ever works without a neutral leg. So we only want to turn this on once the contactors are activated, and we can let go of the momentary switches. So it seems like there's a lot of steps in here, but I mean, you got to understand this is a power station, and you want to have reasonable security protections in when you have a power station. So let's go ahead and turn this system on and check it out, see if it works. Okay, I just wanted to kind of go through some final circuitry, show you the whole thing, what it looks like when it's put together, and kind of walk you through the startup process of how this kind of circuit design would work to protect you against a neutral failure, and just give you a safe way to start these Growatt ES5K inverters. As you guys have known, you guys may know or may not know, there's been quite a hubbub on the internet about these inverters, because Signature Solar has created a model of this inverter which is very cost effective, that works in the US. If you get them from other places, import them yourself, you could run into a potentially dangerous situation where the neutral leg is grounded to the line leg, and that works in Europe, but in North America, those cannot be bonded together. That would be very bad. So anyways, we wanted to put together a safer way to set this up, and then also get some monitoring in on the auto transformers. Now, the next thing we're going to be doing is hooking up some heat monitoring to those auto transformers, so we can also kill the system when the auto transformers overheat. So let's go through this step by step here, and right now you can see that the whole system's on, and see our breakers are on, everything's running. You can see the voltage protection relays are both engaged. So I'm gonna go ahead and turn it off, and you can see, watch, let you see what happens. See, when I turn this off, not only did my contactors disengage, when the contactors disengage, that kills the hot for the whole system. So at that point, the hot, as soon as these contactors close, the hot legs, those hot legs are no longer allowing electricity to either go to the auto transformers or also out to your loads. So it's a hot kill for the circuit that feeds auto transformer, circuit that feeds your actual loads, and it's kind of what you're looking for it to do. So the other thing that happened is the shunt trip breaker closed itself, and the reason that I've got it designed like this is the shunt trip breaker, we want that to be a one-time reset. So if I try to reset this thing right now, you'll see that it just goes right back off, right? Because the contactors aren't engaged. And if contactors aren't engaged, then I should not be able to turn my loads on without the system being in operation. So that's kind of what the design is here, and you can see it's all powered off, all kind of powered down, but still can't turn that breaker on. And the reason is because these things, my Growatts right now, are outputting 240 volts. So let's kind of go through some failure modes here. We're going to turn these off. We're just going to turn them right back on, and I want to show you that this, I can turn the shunt trip breaker on now, right? And I'm going to turn the power switch on. And this is like a cold start of this system. So we'll go ahead and flip these guys back on. We've got them in standby mode, so now it'll take a couple minutes for them to start outputting 240 volts again. And as soon as they do, what you're going to see happen, and we've got the whole system turned on here, just see happen is that we didn't have a neutral, so it turned off, or turned the shunt trip back to down. So that way, power still can't flow through here because it flows from our primary rail up here from the Growatts down through the contactors into this secondary rail. It comes out of the secondary rail. Now this secondary rail right now is not hot because the contactors are not activated. And our shunt trip breaker closed at the same time. So there's no way to have power in this system and then without having a neutral leg. Without having these contactors closed, there's no way to have a failure event and not know about it. So let's go ahead and walk through the steps to activate the system. So we've got our, we got our on-off switch, which I kind of like to have on-off switch so I can turn it off if I want to do maintenance or something. So we'll go ahead and turn it on. We'll push and hold these two buttons, which activates our contactor. You see the lights turned on our voltage protection relays. I'll let the buttons go, and then the system runs itself. And that's pretty cool. So now I can go ahead and close my my shunt trip breaker, and I'm good to go. I can start putting loads on this, and we're going to go ahead and throw a load on it or two. So let's come over here to our power panel. Put all these on the generator. Now I'm putting a whole bunch of loads. So we've got 6.5% on each one. So let's go turn the well pump on, or water pump. So I've got a water pump that operates the. So this is a 120 volt water pump. We'll see that this thing is going to put a load on here. Now you can see 17.2, 13.5. If I take my meter and put my meter on here, let's see, I've definitely got electricity flowing through this thing. Go up in here. There we see we've got 7 amps on our neutral leg. Pretty cool, huh? So this all works pretty efficiently. This is about as efficient as I could get things. It should be able to switch up to 63 amps of current. So right now this is only a 50 amp breaker down here, but I do have a 63 amp breaker en route in a 3-pole. Yeah, so let's go ahead and simulate a neutral failure and see what happens. So we'll turn this one off, and we'll turn this one off. Yep, see that? So let's go ahead and turn those back on. Reactivate my system. Done. Yeah. You see the load came back on. If you got any questions, please let me know. I will run through this very quickly once more. So we've got our shunt trip and our outputs to our fuses and our shunt trip wired off our primary rail up here. These come out and out of the fuses that comes down into this switch back here. That switch in turn goes over to this blue and yellow side of the rail. That blue and yellow side of the rail goes to these red and black bus bars. They come out of here. They go through the normally open side of the contactors. They come up to out of the normally open side of the contactors into each of the voltage protectors. Out of the voltage protectors into this orange and gray rail, and they come out of there and into the top side of the contactors. At the same time, we also have our momentary bypass switches, which follow the same current path but allow us to bypass the voltage protection relays to activate the system. That's all I got. So if you like the video, please let me know. If not, also let me know. Have a great day, everyone.